All right, so I got a couple more homework problems. These word problems are also in 6-7, page 550. And if you haven't done them, it would be great for your study to do these first before you watch me do them. So I encourage you to pause if you haven't done them and work out the problems. Okay, well, let's give it a shot here. I wrote down a few things that we already know. The tumor is injected with 0.5 grams of iodine, 125, which has a decay rate of 1.15% per day. So we're going to let T equal days after the injection. We've got an initial amount of 0.5 gram, and we have a decay rate of, now that is not the right decay rate. So it is 0.0115. I left out a 1 there on that. Let's build a model for this medicine here. We can use the model. Medicine equals, I could use drug like I did in the last problem, but we'll do A, B to the T power. Now we could also do exponential base E if we convert the rate into a continuous decay rate, but this is going to be fine. So we have the medicine at the time with the initial amount, 0.5, and we need B. B equals 1. In this case, it's decay, so I'm going to use minus R. So B is going to equal 0.9885. to the T power. Okay, so they want us to find time. This problem number 32, it's find time for the medicine to equal 1/2 of 0.5. Well, half of 0.5 is 0.25. So I'm going to put that in my equation here. 0.25 equals 0.5 times 0.9885 to the T power. And I have to solve this. So divide both sides by half. And it turns out to equal half. Maybe I should have put this over here. And if we do a log on both sides, I'm gonna do the algebra step in red. Then I can get an equation, so I can use the log rule. Let's make this all fit better. 0.9885, and if I divide, I will get log of 1/2 over log of 0.9885. There is an exact solution. So let's type that in the calculator and see what comes of it. Okay, you can see how I've entered it in the calculator over here on the side, and we get T equals 59.9. Well, we can just call that 60 days. So let's make that better. So in 60 days, it takes 60 days for the medicine to be metabolized to half of its original amount. Okay, we had another question, a follow-up question, number 33. It says, write an exponential model that represents the amount of iodine 125 remaining in the tumor after T days. Well, that actually is just a repeat. We've already done that work. The medicine is 0.5 is my initial, and it's 0.9885 to the T power. And after 60 days, well, that's a crazy problem. So what we're going to find out is it's just a repeat of number 32, except it went the other way. Before we found the half-life, this time we're finding the time. We're just going to take the 60, plug it in. And when we do, we plug in that 60, and let's calculate that and just confirm. All right, if you look over on the left, you can see I typed it into the calculator. We can hit enter, and we find that the amount in 60 days is approximately 0.249. Well, that's basically 0.25 milligrams. So these two problems are just reverses of each other about half-life. And it says that the half-life is achieved 0.25 milligrams in 60 days. And the other problem said in 60 days you get 0.25 milligrams, which just happens to be the half-life. So I don't know if they meant for these problems to go back and forth like that, but that's kind of what worked out in this assignment. Okay, I have two more. Now the next two are actually the two that I assigned to you, so I encourage you to keep watching so that you can check your work from your homework tonight.